All right, so we're going to use the same method we used on the previous video to answer the question in the second card here. Okay. So what we're going to do is we're going to take the integral from a to g of x of f of t dt. And we're going to say it's equal to big F of g of x minus big F of a. You're already thinking about what we did in the last video, where we know we're going to take the derivative of both sides. That little f of a is going to go away. Let's show it. All right. So we want the derivative with respect to x of the left side. And the derivative with respect to x of the right side. Just enough room, okay. Then, make u smaller. We're just again going to focus on the right side. It's the derivative with respect to x of big F of g of x. And then the derivative of big F of a, again, is 0. So I'm just going to drop that. This thing right here, that becomes 0. So you're not going to see me write that down anymore. Okay, now what I want to do is I want to take this and rewrite it in a different form. So it's going to be, well, the derivative of a composition would be the derivative of the outer evaluated at the inner, so big F prime of g of x times g prime of x. And then one last thing for me to do is to come in and change the name of big F prime, using the fundamental theorem, to little f. So, if I can make that smaller, my answer is going to be little f of g of x times g prime of x. And you can see how the chain rule shows up in the process of evaluating this antiderivative because, the derivative of an antiderivative, because it is a composition. The integral itself is a composition. Now you might be wondering about the first problem. The first problem is also a composition. But remember, we would be multiplying by the derivative of x with respect to x, or dx over dx. And dx over dx is just 1. So yet again, even on that first problem, chain rule was part of it. We just got lucky because the chain rule factor was 1, so we left it off.